So now we're moving on to a new problem. That is problem number 2290 on LeetCode, which is a LeetCode hard problem, which is minimum obstacle removal to reach corner, right? So you are given a zero index 2D integer array grid of size m cross n. Each cell has one of two values. Zero represents an empty cell and one represents an obstacle that may be removed. You can move up, down, left, or right from and to an empty cell. That is four directional movement. We need to return the minimum number of obstacles to remove. So we can move from upper left corner, that is 0, 0 to the lower right corner m minus 1, n minus 1. And for example, we have this grid, so 0, 1, 1, 1, 1, 0, and 1, 1, 0. So this means that wherever we have 1, it is an obstacle, and wherever we have 0, it is an empty cell. So we can remove the obstacles at 0, 1 and 0, 2 in order to make this so that we can easily traverse from the top left cell to the bottom right cell. So we need to remove at least 2 obstacles. That is, the answer is 2, right? Now this is another problem where we have been given this array. So you see that the obstacles have not been placed in a way, so we can easily move from here to here. That is, there is a path existing. Without the obstacle removal, we can also reach. So that takes 0 cost. So 0 obstacles removed. So that is basically the problem. That is minimum number of obstacles removal in order to reach the bottom right. So for this problem, let me just share the code. So we'll make an isValid function which would be checking whether the coordinate that we're moving to, that is x, y, or I, j, whether the coordinate that we're moving to is within the bounds of the grid. That is, it does not go outside the grid bounds. So for example, in this case, we don't want to go out of bounds when it is traversing. So we want it to stay within. That is why we have this condition. M is the number of rows and n is the number of columns, right? And I have defined a pair of int int. I have named it as pi. So that's the alias name. So vector of pi of directions is basically the 4 directions that we can move in. 1, 0, which means that when we add to our existing xy, when we add 1, 0 as this vector, so it would mean that we are moving x plus 1, right? So if you see x, which is basically on the x coordinate, we move 1, and in the y coordinate, we're moving 0. So that means that we are moving towards the right. No, we are moving towards the down. Basically, this means that x plus 1, right? So x coordinate, it's not about coordinates, it's about this is x equal to 0, this is x equal to 1, right? So we are going to move down since the y is not changing. No, I think that's correct. That's right, is correct. And then we have minimum obstacles. So we have this grid. We're taking the grid, which is the matrix. M is the number of rows, n is the number of columns. Now we need to find the minimum number of obstacles to be removed. So when the keyword minimum strikes, which is basically related to shortest path, the Dijkstra algorithm comes up to the mind. So that's our first thought. That is where we build the intuition from. So we're basically going to maintain a priority queue of pair of int int type. So it would basically be taking 3 values. It is the minimum heap. It takes the minimum obstacles that we have covered so far and the x and y coordinates. And we also maintain a distance vector to keep the minimum distance matrix to give the minimum obstacle count to reach each cell. And we first push the top left cell, which is basically grid of 0, 0. So these are the coordinates, and since we have 0 obstacles removed initially, so we push that in. Now we have to use the Dijkstra algorithm, and we also set a distance of 0, 0 as 0 because we have not removed any obstacles till now. Now it's the standard BFS approach, the Dijkstra's algorithm approach. That is, while the priority queue is not empty, we get the current element from the priority queue. That is by extracting it using pq.top and then popping it from the priority queue. So first is the minimum distance, which basically is the minimum obstacles that we have. Then current dot second dot first would be the x coordinate or the ith coordinate, and the jth is basically the y coordinate. Current dot second. Now we go over to all the directions and get the basically the 4 directionally we have to access the next neighboring cells. So in all 4 directions of the x and y coordinate, so basically 4 directions we are covering. So we check if the next nx and y is basically the cell are basically the cell coordinates for the next or the neighboring cell. So if this is valid, if this cell is valid, that is it is within the bounds of the grid, then we basically set a variable new distance, which would be the minimum distance plus the actual grid that we have. So the grid values that we have, in case it is 0, we basically mean that it is a free cell, that is an empty cell, or it can be one that is we have to remove it using an obstacle. So that is the cost to move, right? So if we check if the new distance is less than distance of nxy, then we push it into the priority queue, the new distance along with the coordinates of the neighboring cell, and we mark the distance matrix at that coordinate, that is nx comma ny, at that cell with the new distance that we have achieved since it is less. And finally, we have to return the minimum obstacles. So this basically does the minimum function, and minimum obstacles to reach bottom right cell would be stored in the bottom right cell, which is distance of n minus 1 comma n minus 1. Let me just submit it to show you guys how it is working. And yeah, it's been accepted.